This is the notes for day 2 of 9.1. We're really just going to go over what we did in 9.1a, and today for homework we'll just continue our work on the bookwork and we'll have a short worksheet. So again, we need to have an understanding of how to graph what I would call simple parabolas. There are ones where the vertex is located on the y-axis or at 0, comma, and then we'll discuss what that is in a second. So in order to understand how we graph them, we kind of have to know what these numbers are doing to the graph. And we talked yesterday about the parent function, about how the parent function is the graph of y equals x squared. And it's a very average looking opening up parabola. And we talked about the effect that the addition of a number out front, like say 3, and a number off the end, like say 7, has to the graph of that parent function. What do they do to it? And so let's take a look here. I've got two quadratic functions here, two parabolas represented by their equations. One of them's y equals negative 2x squared. The other one's y equals x squared plus 3. And the first thing I'd like to do is just go over here on the side and ask a question. And the first question is, what does that negative out front do to the graph? And again, right here, what's that going to do to my graph? And the answer is, because the y's will be the opposite, and y is the up and down motion of the graph, what's going to happen is it ends up flipping it over and makes it open down. So it makes it open down or make a frown. So think a negative, frown, open down. All right? My other question that I'd like to ask is, what does the plus 3 right here do to the parabola or do to the graph? And remember what that does, adding that on, is it says the y's are x squared, it's the parent function, y equals x squared, but all the y's are going to have 3 added to them. And the y-axis is our up and down movement on the graph. And so what that does is it moves the graph up, moves the parabola up 3. Had that been a minus 3, it would move it down 3 along its axis. So putting a negative in front makes it open down. Adding a plus 3 on it moves it up. So let's compare and contrast these. What is similar about them? So when I compare them, what is the same? Well, first of all, their shape is the same. They are both, and in class, we come up with these together, but on these video notes, I got to do it by myself. They are both parabolas. They both make either basically smiles or frowns, okay? When you graph them. Their graphs are parabolas. What else is the same about them? They both are called quadratics. They are both what we call quadratic. Let's underneath that put what that means. Degree 2, highest power, all right? They are both quadratic functions. So they're both quadratic functions. They both make parabolas. They both have a vertex. It's not at the same spot, that they both have one. They both have an axis of symmetry, stuff like that. More importantly is what's different about them. So before we go graph them, letter A, because of the negative, A opens down. So when I go graph that one's going to make a frown. All right? Whereas B, so here's my comparison. Here, let's write contrast. What's different about them? Contrast. All right? A opens down because it leads in a negative, whereas B is going to open up because it leads in a positive. All right? What else is different about them? A has a vertex at 0, comma. By the way, that could have been, they both have a vertex at 0, comma something, is something that's similar about them, but what I put in this slot here is different on both. A has a vertex at, well, let's put 0 in for x. Negative 2 times 0 squared is negative 2 times 0, or 0. Whereas B has vertex still at 0. And again, by b, I mean this one. When I do 0 squared plus 3, I get 0, 3, which shouldn't surprise you since we said it moves up 3. Obviously, the vertex would move up 3. What else is different about them? Let's talk about their width or their thickness. All right? You would think that the negative one might make it either thinner, or you might think the big number makes it better, but we have to think it through. Remember that negative sign simply makes it open up or down. This gives it a frown, but it doesn't affect its width. The 2 stretches it to twice where it was, so it makes it narrower than when this was at 1, or the same width as the parent function. So what else is different is parabola A is narrower than B. Alright, now let's go graph both of them. Alright, how do we graph them? Let's say we had to do it by hand and not on our graphing calculator. We would make a table for each one of them. I'm going to put the table for A here, and I'll put the table for B in the middle here. And A's was y equals negative 2x squared. So when I make a table for that, again, a little repeat here, I need to find my vertex, which is at 0, 0. We already said that. And then I'm going to put some nice numbers in because I simply need to multiply them by a negative 2. I'm going to choose 1 and 2. Those are almost always my choice unless I have a fraction out front. And again, if I had, say, a half, I'd pick evens. If I had a third out front, I'd pick multiples of 3. If I had a fourth out front, I'd pick multiples of 4. We want to make our life easy. So when I put in a negative 1 and square it, I get 1 times negative 2 is negative 2. Again, follow the rules of order. When I put a 2 in for x and squared, I get 4 times negative 2 is negative 8. So notice it is going to be opening down here, and it's getting very stretched out because of that 2. So what I said was going to happen, happened. This one made a frown, and it made a very skinny or narrow frown. And that is the graph of parabola A. Parabola B was y equals, I forgot what it was, I gotta scroll up here for a second. It was y equals just x squared plus 3. Right, so again, I make my table of values. My y is going to be equal to x squared plus 3. I'm going to use 0. 0 squared plus 3 is 3. So notice that vertex got pushed up 3 on the axis of symmetry. Oh, there's another thing that was similar. Let's put this. They both have y-axis for their axis of symmetry. I'm just going to put for symmetry because I don't have room in here. Alright, so I've got 0, 3. 1 again is my most logical since there's no fraction out front here. I'm just going to put in a 1. 1 squared is 1, plus 1 is 4. 2 squared is 2. I'm sorry, plus 3 is 7. So I'm going to go 1, 4, and then 3, 7. It's going to be kind of up here. I use some symmetry. It's going to look like that. So you'll notice what happened here. We'll review. All right, so last step. In our summary, it's really important again that we understand several things here. First of all, the number out front, or in front of x squared, affects 2 things. 1, up or down. Basically, smile or frown. And that's if it's positive versus negative. It also affects how wide it is. So let's put its width. Alright? It's going to be quite narrow if A is big. 2, 3, 4, 5. Actually, it's the absolute value of A is big, but we won't get too picky. It's going to get quite fat if A is a fraction less than 1 in absolute value. And again, like if I were to think of what the equation for this one might look like, it's opening down, so it would have led in a negative. It's very fat, so there would have been a fraction out front of it, maybe 1/4 x squared. And I don't have my axes on there, so I can't put the plus or minus c on there. And then last, all right, the number added on the C moves it, or the parabola, up, if it's positive, or down, if it's negative. So that's it for today. Just a quick little recap of yesterday.